the outputs and the behavior, linear behavior of basically all these configurations. Okay, and here we have some output of 2500 generations as well. So we are just focusing for autoencoder variation over time fitness function. So the directory structure looks like applied computer science project, linear AE combined, and experiments. And then we have AEVoT, and here we are. So we are using this configuration first with the so these are variation over time threshold. A live cell threshold is 0 0.5, and we are considering all 100 frames. And for the autoencoder, basically it takes 64 by 64 image as input, because the board size is also 64 by 64. So all these are this is code, this is the output, this is also the output, and this is what we are seeing right now, the basically the output. So let's shrink it a little bit. All right, so that should be fine, I guess. All right, so what we are seeing right now here is for this configuration, we are using this configuration, the first file with its output. So first generation has the output looks like this, with the kernel plot looks like this, while let's say something middle, the kernel plot looks like this, and the output looks like this for AEVoT. And maybe in the last, okay. So one thing is worth noting here is like it shows generation 406, because after 406 till 500 generation there was no progress. So the elite which exists at 406 is same at 500 generation, and this is the output for it. Okay, so now we are seeing this configuration basically to AEVoT, population 10, generation 500, mutation 0.2, alive cell threshold 0.5, and last 10 frames. So last 10 frames was actually not performing well, which when we were basically testing it, and not working well on terms of fitness values or fitness plots. So it found elite at 202, and it stayed at 500 generation. So let's check for this configuration. Okay, so the configuration here was every 10th frame alive cell threshold 0.3. Okay, okay. Then we have a configuration of alive cell threshold 0.3 and last 10 frames. Okay, then we have a configuration of 0.5 alive cell threshold and every 10th frame. So here we have seen a lot of variation over the frames, because the fitness function is like first reconstructed and then check for the variation, right? And it can be seen by visuals as well. Let's check some middle configuration also. And yeah, here in middle generations itself, it found a good kind of variation behavior. Okay. And to add, we are running this configuration for 2500 generations as well, particularly because as you can see here, we have 2500 generation threshold 0. 0.5 every 10th frame, threshold 0. 0.5 every 10th frame. Okay, for 0. 0.3 threshold, 100 frames. Let's skip this for now. We have a life cell threshold 0. 0.1 and every 10th frame. This should be worth checking because we want to compare it with different alive cell thresholds for every 10th frame, because every 10th frame function, wherever we are using every 10th frame as fitness function, it's performing well either in VOT or in AEVoT. Okay, so this is the configuration threshold 0. 0.1 every 10th frame. So these are two different experiments for the same configuration. Okay, not much progressive though. Then we have 2500 generations, right? So we have output looks like this at 0 generation, and for 2500 generation the elite was founded 1904 itself. So all the running after 1904 was not useful basically, and this is the output for 1904 generations. Okay, then we have these five-fold, basically five experiment for the same configuration, which we talked about. Basically, this configuration, which actually performed well on fitness plot, which you can also complement it in the report. So this is all about AEVoT.